Hello everyone, I'm Bao Yiwei from Beihang University. I'm glad to introduce you our CVPR 2024 paper on supervised gaze representation learning from multi-view face images. Deep learning-based gaze estimation methods have made a lot of progress in recent years. These methods often require large amount of labeled data for supervised training. However, gaze label is difficult to acquire. Gaze directions cannot be labeled manually. They are usually acquired through complex and calibrated settings or expensive eye trackers. Thus, collecting large amount of gaze label for supervised training is difficult and time-consuming. To reduce the dependency on labels, researchers have proposed some unsupervised learning methods. Without gaze label, these methods usually use eye images as input for less interference. Face images provide more helpful information such as head poses, which is more robust to large head movements. However, this information is difficult to separate from gaze without label, making this rich information a double-edged sword. To tackle the difficulty of face-based unsupervised gaze representation learning, we propose to harness the extra constraint introduced by multi-view images. Since images from different views are captured simultaneously, the eye rotation of these images are consistent. We utilize this consistency to separate gaze from other facial features. Specifically, we propose the multi-view dual encoder framework. The proposed method trains two encoders separately to extract face and gaze features. First, we mask the eye regions and train the face encoder through image reconstruction and head pose estimation tasks. The target of the face encoder is to extract general facial features without gaze information. Secondly, we train the gaze encoder to extract gaze features. In this phase, we first extract the face and gaze features through corresponding encoders. Then we combine them to reconstruct the original image so that gaze features supplement the missing gaze information in face features. However, the extracted gaze features may still contain general facial information. We utilize the multi-view setting to exclude facial information from the gaze feature. Since the gaze feature from different views represent the same head coordinate gaze, we swap the gaze features from different views and constrain the model to reconstruct the correct image. In this way, we exclude general facial information such as head pose from the extracted gaze features. We validate the proposed methods through two downstream tasks. First, we compare the SOTA unsupervised gaze representation learning methods in few-shot gaze estimation tasks. The proposed method outperforming SOTA methods significantly in two datasets with large gaze and head pose range, showing better robustness towards head pose changes. Secondly, we evaluate the proposed method through gaze redirection tasks. Results demonstrate that the proposed method separates gaze from general facial features successfully. Lastly, we combine different gaze representations linearly for gaze redirection. Results demonstrate that the extracted gaze features exhibit good linearity invariance. Thank you very much for watching. Follow us to learn more about our works.